So in question 13, and this is essentially going to be part A here, what you're given is the function y equals x cubed, and it goes from 0 to 1. So A is 0 and B is 1. This guy at the top is essentially the general way to find the exact value of any area under a curve.
Right.
So that a lot of these things are going to get replaced by other things using this information here. So are you happy about the delta x is 1 take away 0 divided by n, which gives me the 1 over n? Are you comfortable where that came from? Right. Yes. And so what we did here is we went and said, okay, we said that A is going to be the limit as n tends to infinity or sigma I equals 1 to n. Now that was okay because they actually gave you that in the question. So now we need a delta x, and they've put the delta x at the end. So that's where the 1 over n came from.
Right.
And then the bit that goes here is the value of the function x cubed at a plus I delta n. Now a is 0. Delta x is 1 over n, and I times that gets you I over n. So that's basically what x looks like. So x cubed becomes that cubed. And then what we did is we just spent a couple of lines making it look pretty. That's I n cubed, so that's I cubed over n cubed. And then it's times a 1 over n. And then combine the n's on the bottom together and you got the answer to A. So that bit you were happy about, right?
Yeah, I got that part. I actually don't know what I means.
I is just the counting variable. So in sigma is 1, and then you make it 2, and then you make it 3. So here it would be 1 cubed over all that stuff, plus 2 cubed over all that stuff, plus 3 cubed, plus 4 cubed, all the way to n. So we call it counting variable. In sigma, when you write down things, let's finish this guy out of the way first, and then do a side issue.
Okay.
Sigma is a convenience in mathematics. It allows us to write down big sums without the hassle of writing down the individual terms. Right? So if I was going to add a whole load of things together, I'll call them A1, add A2, add A3, all the way to A, say 100, just for example. Then sigma notation would say I equals 1 to 100 of A I. And we would interpret that as you're going to add up using the numbers I equals 1, 2, 3, 4, and finish at 100. And can you see that would be just another way of writing that? And so when you plug I equals 1 in, you get A1. And then you add, sigma's about adding, I equals 2. You get that guy. Add. I equals 3. Add. When do I stop? I stop
100.
At 100. Now it's much easier mathematically to write that than it is to write this.
Right.
And so that's what it is. It's just a convenience, a way of writing a whole load of things added together in a very compact form. So the guy you've got is a little bit messier than that, but it's essentially that. The I is not that important. Do you know that mathematically k equals 1 to n, of k cubed over n to the 4th has the exact same meaning? 1, 2, 3, 4, and finish at n. Don't know if that helped or made it worse for you.
I don't know.
It basically is just a convenience, a way of adding up a whole load of things. So what we're saying up here is that you're adding up lots and lots of strips. In fact, you're adding up n of them. And with a little bit of tidying up, we figured out that each strip has basically got that area.
Oh, that makes sense because n is approaching infinity. So you don't want to I get it now. It clicked.
Good.
Thank you.
Now, part B.
Yeah.
You are being told that 1 cubed plus 2 cubed plus 3 cubed plus all that, right?
Mhm.
Is equal to, well, all the way to n cubed. That thing there, you're being told this nice piece of information. You're being told that it's equal to that. And we are going to use that to find this fella.
Okay.
So let's see how that works, right? I start off with the limit as n tends to infinity, and I do sigma I equals 1 to n of I cubed over n to the 4, right?
Mm-hmm.
And then n is considered a constant here. It's just a number. We might not know what it is, but it's a fixed number, whatever it ends up being. Right now, forget about this bit. So what we are allowed to do with sigma, any kind of adding, is that you can bring out that piece outside. And that means you only need to focus on this piece. You see that n to the 4, if you bring it out, it becomes a 1 over n to the 4, and what's left behind is just the I cubed.
Mm-hmm.
Okay, now, this fella up here, it would have been nice if they told you what it was the same as. It's the same as I equals 1 to n of I cubed.
Mm-hmm.
Which means I can take this and use that. So I now have the limit as n tends to infinity of 1 over n to the 4, and sigma of I cubed is this fella. Right, so there's no more need for sigma. It's basically that guy. So the sigma has disappeared and been replaced by just a single expression using n's.
Right. Okay.
And then at this point, we're really just doing a little bit of algebra and then solving it.
Okay.
So what I'm going to do is square, square, and square. So that's n squared, n plus 1 squared, and 4. And then this guy and that guy's going to partially cancel. So I'm now going to get 1 over n squared, n plus 1 squared over 4. I'm going to multiply the two bottom guys together to get 4n squared, and I'm going to FOIL out the top to get that. So it's now this. And then at this point, can I solve it by L'Hopital or divide top and bottom by n squared? So that gets me 1, 2 over n, 1 over n squared over 4. And then you do a brute force on it, 2 over infinity, 1 over infinity squared over 4. That's 0 and that's 0, so 1 plus 0 all over 4. Whew! After all that hard work, we finally got the answer as a quarter, which is all that we're looking for.
Okay. It's
Now
been a while since I've done the limits.
Right. So there are 3 limit techniques that in these questions here, you're probably only going to use the divide top and bottom by n or n squared or n cubed kind of situation. But these are very, very cumbersome technique. Would you agree it takes you 20 minutes to do one question? And that's why once we've done one, we say, look, all those shortcuts I showed you at the end, I could have done every single one of them using this technique to prove to you that they worked. But then instead of 15 minutes to do 15 questions, it would have ended up being 10 hours to do 15 questions. And so we always like shortcuts, don't we, in math? And so once you've seen this, you can say, okay, if I had to prove it the hard way, I have a method. I just choose not to do it that way because the shortcut's so much quicker.
Yay.
Okay, a yay is good. Anything else?
Hold on.
Right. Do you mind if I keep this video and put it online so that
Yeah.
other people can look at what I did?
Yeah, that's totally fine.
Okay, thank you.
And then would number 14
Mhm.
be basically the same, just with 4 and 7?
14 is a lot easier because in 14, you don't even need to simplify it. All you need to do in question 14 is set up the big ugly sigma.
Okay.
So here is the question, and here is X. So in this case, A is 4 and B is 7, right? So in general, it would be sigma. Try to use the same guy I used at the beginning. So it's going to be F of A plus delta xi times delta x, right? And it's going to be I equals 1 to n, right? And then the whole thing is stuck inside the limit. So what we're being asked in question 14 and the others, I think the other one after that, is to make this a little prettier. In other words, to try and replace some of these things by numbers, or at least things with n in them, because the question is going to have n strips, right? Because of this, I can tell you what delta x is. It's a take away b over n. It's 3 over n. Which means that this question, this is kind of the intermediary stage. It would become a little bit nicer if we thought of it as the value of the function at a, which is 4, plus delta x, which is 3 over n, I. So I'll call it 3i over n, times delta x, which is 3 over n. Would you say that's a little bit prettier? A little bit more numbers, a little bit less. We can do a little bit more than that, but just a little bit more. Because I know that f of x is this, can I replace these two x's with that expression and we're finished? So the final answer, the only thing you need to do, and then you're over with it, is to replace this piece with that guy. So instead of 4 plus 3i over n, that goes there, it's going to be x, which is that guy, right? Plus the natural log of x, which is also that guy, times 3 over n, and you're finished. So you're not actually needing to do, you know, that 2-page stuff that we did in the previous question. They just can get to there and call it good.
Okay.